All right, we're back for page 2. Sorry about the last video being zoomed out. Learning curve here. If I can't get the audio right, what am I else going to get wrong? It was something weird with the program, but I think I've got it zoomed in now, hopefully. And maybe that'll clear it up for you so you guys can see the problem as we go. So right now we're going to find the lateral area and the surface area. And remember, these are two different things. The lateral area is the area of all of these faces that are triangle shapes here. So we're going to add those together, and then we're going to add in the final pentagon at the bottom. So let's start by looking at the area of the pentagon. And we said that that's going to be that new formula, 1/2 perimeter times apothem. So the perimeter of this pentagon, there's 5 sides, and each side is going to be 8 feet. This is 8 feet all the way around. So that's your perimeter. And then the apothem is going to be this 5.5 feet. All right, so that means that I'm going to basically have, well, half of 8 is 4 times 5 is 20 times 5.5. Well, 20 times 5 is 100, and 20 times a half is 10. So I think that's 110 square feet. Okay, so there goes our base. Now everything else is going to be the lateral area. So let me just find the area of one triangle, because all these triangles are going to be the same since this is a regular shape and 8's the bottom for all of them. So this is one triangle, and the base of this triangle is 8, and the height of it is this slanted height going up, not this what we would call standing height. We don't want to find that. That's not the height of this triangle. The height of this triangle is longer than that. It would if you had to slide down this hill and somebody else just jumped off this hill, they have a shorter distance to fall. You have a longer distance to slide. So even if you guys went at the same speed, they would reach the ground first. Just like taking a shortcut across between two roads or something. So as we go, this is 10.6 feet for the slanted height, and this is 8 for the base. So my base is going to be 8. My height of this triangle is 10.6 feet, and that's going to be divided by 2. Once again, I can do 4 times, so 8 divided by 2 is 4. 4 times 10 is 40. 4 times 0.6 is, what, 2.4? So is that going to be 42.4, I believe. Hopefully I'm not making mistakes here. 42.4 feet squared. That's for one triangle. So the lateral area is going to be equal to 6 times the area of each triangle. So that's going to be 6 times 42.4 feet squared. Mr. Conaway, what are you talking about 6? It's 1, 2, 3, 4, 5 triangles there. All right, there's 5. Okay, so 5 times 42.4 feet squared. See, that's the good thing about being, being confident about what you're doing in math, is that you're okay with making mistakes because you know you're going to go back and find them and fix them. There's nothing wrong with that. That's actually a good quality for you, is to be okay with knowing that you can make a mistake and you can actually recover from it and come back and fix it. So this would be 5 times 42.4 square feet. 5 times 40 is 200. 5 times 2 is 10. And 5 times 0.4 is 2. So that's 212, I believe, feet squared. Hopefully I don't make a mistake, but like I said, I don't really mind because I can always come back and fix it if I'm wrong. Let's see. That's the lateral area, but the surface area is when we add in this original pentagon base. So I'm going to have the lateral area of 212 feet squared plus the pentagon base of 110 feet squared, and I'm going to add those together, and that's going to be 322 square feet. And we're done with that one. Not too bad, right? Getting a little bit better at these. So it's just taking these apart and finding the different shapes. Now, when we start doing the height and everything, we're going to end up needing to use this triangle that we've drawn in here. This triangle made out of the standing height, the slanted height, and the radius or the apothem of this shape. We're going to use that triangle to help convert between the slanted height and the standing height. Okay, so let's move over to number 8. We have a triangular prism here. And, man, this could get messy. I mean, are all these triangles the same? Are they different? What are they? Well, luckily we can see that this is 9 for this side. This is 9 on this side, and this is 9 on this side. So that means that the base is the equilateral triangle. So I'm going to do the area of the base first. That's an equilateral triangle. They've given me the height of the base is 7.8. So 7.8 is the height of the base, centimeters. And then the base of the base is 9 centimeters, and that's going to be divided by 2. So that means it's 9 times 7.8. Pull out my trusty calculator here. 9 times 7.8 divided by 2, or times 0.5. 351 over 10, so that's, what, 35.1, right? Centimeters squared. Okay, so let's look at the area of these triangles. Now, are these triangles going to be the same? Sure they are. They've each got 9 for the base, and they're all meeting at the same point, which tells me that they're going to share sides, and therefore we know that we're going to find that all 3 of those shapes are going to be the same. So the area of a lateral triangle, the area of one of these lateral faces here, is going to be the base, which is 9, so 9 centimeters is still the base, times the height of that triangle. The height of that triangle is the slant height, 11.3 centimeters, divided by 2. So multiplying that out, I'm going to get 9 times 11.3 divided by 2 equals 1017 over 20, which is 50.85. And if you wonder why I'm putting decimals on these, it's because I don't mind decimals when they're non-repeating or they're terminating, which means they actually end. But if I have to round, I don't want to use decimals, and I'd rather use fractions. All right, so now we need to go through, since we've got this, we need to find the lateral area next. So the lateral area is going to be these 3 triangles, and we said they're all 50.85. So the lateral area is equal to 3 times the 50.85, which is going to be, well, that's 150 plus 3 times 0.85, which is 3 times 0.85 equals 2.55. So it's going to be 152.55. Okay, and that's the lateral area, but now we want to go back and find the total surface area. And the surface area will be these 3 lateral ones plus the base, the original 35.1. So it's going to be 152.55, and I'm sorry, I just left off centimeters squared twice now. Centimeters squared, plus the 35.1 centimeters squared, and add those together. 187.65 centimeters squared. There we go. So we've got our lateral area and our surface area. And I'm going to do one more problem before I head home for the evening. Hope you guys enjoy this. I really appreciate y'all that are watching these and using these to work on your homework. Let's see. So we've got a rectangular pyramid. Now if we go look back real quick at what we skipped here, these are pretty much all the same. I mean, we've got another pentagon here. We've got a hexagon. It just means one more side. Here's another hexagon. You can follow the steps in number 7 for all 3 of those. And number 10 is very much like one on the last page. Let's see, number 13, that's one with a triangular base, which means that it's going to be similar to number 8. But I'm going to go ahead and do this rectangular pyramid. These are probably the hardest. You wouldn't think it, but rectangular pyramids can be the hardest. So a rectangular pyramid measuring 4 inches and 9 inches along the base. So I'm going to draw this. And this can be a little tricky to draw, and I probably will not do a very good job of it here. there's the bottom. And I'm going to pick some point up here. Let's see. That one. There's that guy right there. Okay. So I tried. Looks like I got a little bit messy on this. But that's my rectangular pyramid. It's rectangular because the bottom's not the square that I want it to be, which means that I have two different types of sides. I have the type of side that's on the triangle that's on the front here, which is kind of a thicker triangle. And then I got the triangle on the side, which is kind of a smaller triangle. So I had to be careful and find both of those. But they were nice enough to give us the slant heights. Now they said a rectangular pyramid measuring 4 inches and 9 inches with slant heights of 10.1 and 9.2 respectively. Now anytime you find this word respectively, that means that with respect to the numbers that were given. So what they're really telling you is go in order. So the 4-inch came before the 9-inch, so the 10.1 goes with the 4-inch and the 9.2 goes with the 9-inch. So that means that if I draw this line down right here, and I draw this line down right here, these are the two slant heights we're talking about, then this one is the 10.1 because it came first, so it goes with the 4-inch side, and this one is the 9.2 inches because it goes with the 9-inch side. So there we go. That's what respectively means. And now I think we have enough to do the surface area of this shape. So let's do the area of the base. The base is going to be 9 times 4, which is 36. And these are in inches. Okay, inches. Good. So that's 36 inches squared. And then the area of, we're going to call the big thick one here triangle 1. The area of triangle 1 is going to be the base of 9 times the height of 9.2. So 9 times 9.2 divided by 2. 207 over 5, which is 41.4 inches squared. Okay, and then the area of triangle 2, which is going to be this thinner one, is going to have a base of 4 and a slant height of 10.1 divided by 2. So that's going to be 20.2 inches squared. I'm sorry that I'm getting off the page here, guys. I know y'all are probably yelling at me. What are you doing, Mr. Conaway? So the area of the triangle 1 and the area of triangle 2, got to remember that there's 2 of each of those. There's a big triangle in the front, there's a big triangle in the back. There's a little triangle on the right and a little triangle on the left. So when I want to do the lateral area, then I got to add those together, and I got to say, hey, look, I've got two 41.4s, 2 times 41.4 inches squared, plus two 20.2 inches squared ones. And I'm going to add all that together, and I'm going to get, 82.8 plus 40.4, 82.8 plus 40.4. Well, let's see, 82.8 plus 40 is going to be 122.8 plus 0.4 would be 123.2. Check me. If I'm wrong, it's cool. Just fix it for me. 123.2 inches squared, and that is the lateral area. One more thing we need to find is the surface area, because that's what they asked us to do up in the problem. They said find lateral and surface area. And we're going to add in the area of the base. So we've got the lateral area, which is the area of the 4 triangles around the outside. Add in the area of the base, which is the 36 inches. So that's going to be 36 inches squared plus 123.2 inches squared. And let's see. 123.2 plus 30 is 153.2 plus 6 is 159.2. inches squared. And we are finito. And I'm going to go home. So, enjoy the video.